Hi, I'm Bob Rodini. I'm an adjunct professor of computer science here at Delaware County Community College. In this video, I will be talking about patterns in math and computer science. Patterns make the world predictable and understandable. They can also be very beautiful. Here's the agenda. I will demonstrate patterns in math by giving examples of closed formulas. A closed formula is just an expression that gives a value. The value must be correct according to some criteria. Next, I will explain regular expressions, which are used in programming languages to recognize patterns in strings of text. The application mentioned in the title pertains to automatically generating a voting aid known as a sample ballot. I will describe the problem and the research and analysis that I did to develop a software solution. Here I am borrowing from my LinkedIn profile. I have a very long programming career, ranging from systems programming to application programming to web development. I was the lead engineer for Vanguard's intranet website called CrewNet. I'm happy to share my career insights with my students. Besides teaching these courses at DCCC, I was also an adjunct in the software engineering department at Penn State Great Valley. And I taught their Java programming courses there also. Here are my degrees. Undergrad at the University of Pennsylvania, plus 2 master's degrees from Villanova University, 1 in computer science and 1 in mathematics. Now here's a career hint to you undergraduates. Try to get hired by a company that provides tuition benefits for advanced degrees. I had my employers cover the cost of both my graduate degrees. In summary, I love math, programming, and teaching. Next, I have a clip from the movie The Man Who Knew Infinity. It's the life story of the Indian mathematician Ramanujan, played by Dev Patel. I claim fair use of this short clip, and I apologize that it's so dark. It's a night scene where Ramanujan explains to his new wife his passion for mathematics.
I want to understand more than just colors I can't see.
What do you see?
Sand?
Yes. Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In maths, these patterns reveal themselves in the most incredible form. It's quite beautiful.
Ramanujan stated that patterns are quite beautiful. What are some other attributes of patterns? I will enter teacher mode and ask you to pause the video and write down some adjectives that describe a pattern. I will wait right here for you. Here's my list. Patterns are recognizable. That is, we can see what's happening. And patterns are predictable, in that you can predict future members from past members. And sometimes they are subtle. It may take a trained eye to recognize a pattern. In fact, many of the applications in artificial intelligence these days constitute the recognition of the subtlest patterns resulting from the analysis of massive amounts of data. So let's look at some patterns in math. I will start slow and then pick up speed. You see the sequence 18, 23, 28, ... What is the next number in the sequence? The answer is 33. And what is the 7th term of the sequence? The answer is 48. There is a formula for an arithmetic sequence like this that goes the nth term of the sequence is the base term plus n minus 1 times the difference between the two terms. Definitely a pattern. Here's another sequence. 10, 30, 90, ... What is the next number in the sequence? The answer is 270. What is the seventh term in the sequence? Answer, 7,290. Here is the formula for a geometric sequence like this. The nth term is the base term times the ratio between terms raised to the n minus 1 power. Those patterns were easy, and their formulas are taught in middle school. Now here's a sequence where I will start in the middle, not at the beginning. It goes ... 463, 467, 479, 487, 491, ... Do any math students out there recognize these? Well, here is the beginning of the sequence. 2, 3, 5, 7, ... These are all prime numbers. A prime number is a whole number that is divisible only by the number 1 and itself. Note that the number 1 is not considered a prime number. It was kicked out of the club, so to speak. The importance of prime numbers was recognized by Greek mathematicians, and they remain a subject of research today. Is there a formula for predicting the next prime? Before I try to answer that question, I will share a website with the URL wolframalpha.com. Please pause the video and go there. If you are on the website, just type isPrime, that is ISPRIME, space, followed by the number you want to test. In this case, I typed 113, and the answer is yes, 113 is indeed a prime number. With this tool, you can quickly test a large number and determine its primality. Now back to the original question. Is there a formula for the next prime? The 17th century mathematician Leonhard Euler observed that the formula n squared plus n plus 41 was good at generating some of the early primes, but not necessarily in sequence. When n is 0, the formula produces 41. 41 is prime. Check. When n is 1, the formula produces 43. 43 is prime. Here are some more values. Now, you can check the values in the p column using Wolfram's site. They are all primes. But what happens when n equals 41? The formula says that 41 squared plus 41 plus 41 should be prime. However, by inspection, this number will be divisible by 41, so it's not a prime. Now, a predecessor to Euler was Pierre de Fermat. Fermat gets a lot of credit for being a top-notch mathematician, although he gave a lot of sketchy proofs. In fact, Fermat's last theorem wasn't a theorem at all because he didn't prove it. Anyway, Fermat conjectured his own prime number generator, 2 raised to the power of 2 raised to the power n, that quantity plus the number 1. Here are the first 5 numbers in the sequence. 0 produces 3, 1 produces 5, 2, 17, 3, 257, 4, 65,537. Whoa! 5 produces 4,294,967,297. Now that's a large number. Remember, at that time, there were no calculators and no computers. All calculations had to be done by hand. This is a good time to use Wolfram Alpha. Euler showed that 4,294,967,297 is the product of 641 times 6,700,417 and therefore not a prime. He did this using analytic techniques, not by trial and error. Of course, you can plug that number into Wolfram Alpha and see what it says. Here's a story about Euler that amazes me. As a number theorist, he had memorized the first 100 prime numbers so that he could quickly recognize patterns within primes. Not only that, he memorized the squares of the first 100 primes, the cubes of the first 100 primes, all the way up to the 6th power of each number. He is considered one of the top 3 mathematicians of all times. Now I will switch gears and talk about patterns in computer science. The patterns we saw in the math area emphasize the predictable aspect of a pattern. The valid math formulas were able to predict the next instance in the pattern. Let's look at the other attribute of patterns, namely recognizable. Can I define a pattern that recognizes instances that match the pattern? That's exactly what we'll explore next, but I want to make clear that in computer science, we will be talking about strings, not numbers. A string is a sequence of letters, numbers, punctuation, and such. Basically, it's just text as you find in a text file. Computer scientists have developed advanced algorithms for areas like string sorting, text searching, data compression, and regular expressions. Here's an interesting description of regular expressions that I found on a website. If you're a programmer who uses regexes, I'm sure you will get a chuckle out of this. Despite being hard to read, hard to validate, hard to document, and notoriously hard to master, regexes are still widely used today. Supported by all modern programming languages, text processing programs, and advanced text editors, regexes are now used in more than a third of both Python and JavaScript projects. With this in mind, over 50 years since their inception, the use of regexes seems very much here to stay. Now I'm going to introduce you to another website with the URL regex, R-E-G-E-X 101.com. I'm afraid I don't have the time to teach you regular expressions. I will just demonstrate them for you. I am at the website and my regex is entered here. The regex looks weird, but it says match a string that consists of 2 digits followed by a /, followed by 2 digits, followed by a /, followed by 4 digits. To see if this works, I have entered the text string area, the string 09/07/2022, followed by a carriage return. Don't forget the carriage return. The website evaluates the regex vis-a-vis the test string and says, yes, there is a match. Different panels on the page give more information about the match that may be interesting to the programmer. Now, regexes are extremely sensitive. If you remove the leading zeros in the test string, you will get no match. This can be fixed, but it requires a change to my regex syntax. And what about an invalid date, such as September 31st, 2022? There will be a match because regexes perform syntax matching and they do not perform any semantic processing. Here are a couple more regular expressions. The first is a simple version of an SSN match. Please don't test this against your social on regex.com. Just type in 123-45-6789 for test data. Here is a more complex regex for SSN matching. It attempts to eliminate some invalid SSNs because the author knows more about SSNs than I do. In short, regular expressions are extremely useful for text processing within a computer application. I call them God's gift to programmers. Here's another regex that I designed to demonstrate some important points about regular expressions. First, here is the pattern that recognizes dates of a specific format. We saw this just a while ago. It's preceded by a capture group, which simply gives a name to the value of the captured string. Now, it's really important to realize that you can skip over text that you are not interested in by wildcard matching. Finally, In case anyone calls me out, the last two characters indicate that I want a repeat of this pattern, but make it non-greedy. What does it look like to the programmer? The Java language's regex API yields all of the information you may need. If there's a match, it gives indices into the string that you can use to isolate text. For a capture group, it gives access to the group by name. And if there are multiple matches, it populates an array whereby you can get the matches element by element. Here is that regex being tested on regex101.com. There are 4 matches to the pattern, which we can see here. Notice that I varied the month value in the dates. The regex is matching on date syntax, not on a particular date. At this point, you might say that patterns, specifically regular expressions, are interesting but not too useful. But here is a problem that I set out to solve at the beginning of this year. First, I am a volunteer for a political party that every year, actually twice a year, must get out the vote for our party members. Part of this effort requires the production of a sample ballot that identifies and endorses our party's candidates. Typically, this sample ballot is a Microsoft Word document that is printed and mailed to our voters. Your first question should be, where does the ballot information come from? The answer in my case is the Chester County Voter Services Office. Voter Services is required to produce a ballot specimen a few weeks prior to every election, listing the contest for the election and the names of the candidates running for each contest. For many years, I have taken the Voter Services specimen and painstakingly created a sample ballot for my precincts by hand, that is, using Microsoft Word. Here is the problem statement. Every election, the Chester County Voter Services releases a giant PDF file with a sample ballot for every precinct in the county. Political parties then produce precinct-level preferred candidate ballots with the names of their party's candidates as a voting aid. The question I had is, can the production of a precinct-level sample ballot in Microsoft Word be automated? Be aware that the PDF file contains ballots for over 200 precincts, all mushed together. Also, the election contests differ every year until the election cycle repeats every 4th year. Let me demonstrate this giant PDF file. Here is the file on my disk. I've renamed it. It is the specimen file from Voter Services, now under the title general-2021.pdf, and you can see it is 8.8 megabytes on disk. I'll double click on it and open it up in Adobe Reader, and here's what it looks like. So this is the first precinct, number 5. The town is called Atglen, which is in the western end of Chester County, and this looks like a common banner. That's the date of the election. Here are some instructions for the voter, basically how to fill in the circles or the ovals next to the candidate's name. And I see various contests. In the first column, there's the contest for the Justice of the Supreme Court, where the voter is to shade in just one candidate. Maria McLaughlin is the Democratic candidate. Kevin Robson is the Republican. There is space for a write-in candidate. The next contest is Judge of the Superior Court. 2 people running for that office. And it continues in the second column, Judge of the Common Pleas. And notice after coroner, we get some local contest. School Direct Octorara, Region 1. There's only one candidate. Lisa has cross-filed. She's running both under the Democratic and Republican banner. That's allowed for school district races. Here is a candidate running for the mayor of Atglen Borough, so forth. And I also noticed that this is a 2-page ballot because on page 2 there are more offices, a judge of elections, one person running, inspector of elections, no named candidate, and on the right column there are votes for judicial retentions. Every judge after 10 years must come up for a retention vote, and you just say yes or no. Now I keep scrolling. I'm down to precinct 10, which is Avondale in southern Chester County. I see the banner for the overall election. I see instructions. They are the same as before. I see the same contests for down the first, second, and third columns, except that at the bottom of the second column, there's a magisterial district judge race between Bobby Brown and Matthew Seavey. And in the third column, there's school district races. And on page 2, there's a contest for constable, judge of elections, inspector of elections, and so forth. And also the same judicial retention questions. Notice that there are 464 pages in this PDF, and if there's 2 pages per precinct, that's 232 precincts. So let me just scroll down all the way to the bottom and take a look at our last ballot. Notice the watermark. These PDFs cannot be used for voting purposes. And here is precinct 860, Westchester 7, our common banner. And if I just scroll around, it looks like the common races are all there. In Westchester, there's a magisterial district judge race and so forth. And again, this is a 2-page ballot. How did I go about this? As a professional programmer, I have lots of experience conducting software projects. I did the following research and analysis. First, I researched commercial SDKs to access PDF files. I quickly learned that these SDKs are way too expensive and I had to eliminate them from consideration. Second, I researched many open source software packages and found 2 that I could work into a solution. The first was a canned utility called PDF Box that could do 2 things. 1, split a large PDF into many smaller PDFs. The other was to extract the text from a PDF file into a distinct TXT file. The second critical piece of open source was an SDK that could generate a docx file. That software went by the name docx4j, the J indicating the API is for Java programming. Next, I experimented with regular expressions against the text of the large PDF file. At the beginning, I wasn't sure that this approach would work, but I concluded that it would with carefully designed regexes. With these in place, I wrote 4 custom Java programs and a script that constituted a solution to the problem. Now I will explore with you the text files, looking for patterns, and then show you how I developed the regular expressions. Let's explore the text file that represents the text embedded in the voter services specimen. Here it is on my file system, labeled general-2021.txt. We'll open it up in a text editor and start looking for patterns. Right off the bat, I see that there's a string called official municipal election ballot. So here's the first hit, and that string is followed by the precinct name and the name of the precinct, 005 at Glen, and then it appears a third time, and we'll scroll down to see how it appears on other municipal ballots. So here it marks the beginning of the next precinct, 010 Avondale, and it just happens to repeat. And here's a third occurrence. And a little more, yeah, same pattern. See, it introduces the Birmingham precinct. So this will serve as a marker for our precinct boundaries. And if we find it, we should be able to find the precinct number and precinct name. Another pattern, well, I'm kind of cheating because I already did this, is contests and questions. So let me search for that. And I see it serves as a marker for the first contest mentioned on a ballot page. Scroll down some more. And here we're into the second precinct. And again, it's marking the first contest name. So that's a useful marker. And I'll be using that in one of my regular expressions. Let's see if we can find another thing that demarcates the contest text. Again, I'm cheating because I've already done this. I'll swipe that string, put it up here in the search bar, and in this case it does demarcate the end of the contest text on the first page. I just did another search and it demarcates the end of the contest text on the second precinct, Avondale. So that's another marker I will use in a regex for finding the contest text. So now let's just concentrate on the very first precinct, and we want to look for the contest names and the candidates. So first I'll swipe it. And it's the highlighted text on the screen. And I should be able to isolate it because I found two other markers that I can turn into regexes to just extract this text. Now, let's look at each contest. There's a contest name, some instructions, and then a list of candidates. This is going to be tougher, but I noticed that each contest ends with vote for. So let's search for that. Okay, and I should be able to use this string vote for in some way to find the contest name, maybe working backwards a few lines. And once I know the contest name, I notice that vote for and write in demarcate the candidate names. And there's a pattern here: name followed by party, name followed by party, followed by write-in. Let's see if that pattern holds. Here's another contest: vote for, name, party, name, party, name, party, name, party. And it doesn't matter if there's two write-ins. I know there'll be at least one write-in. So I can incorporate that information into yet another regular expression to help me identify candidates and their parties. My next step was to develop functional regular expressions using the website regex101.com. Let me congratulate the developers of this website, as it is first class. Not only does it help you understand your regex and why it may not be working, but when it does work, it uses color coding to indicate the match areas as indicated by capture groups. Another feature is that the site stores my regular expressions along with test data. This makes it perfect for me to demonstrate their behavior to you. Here's my data. My first regular expression applies against the entire text of the voter services specimen and isolates the precinct names within the text. It uses the previously identified string official municipal election ballot on one line and expects a precinct number and a precinct name on the next line. As you can see, there are 464 matches through the test string. This regex performs two important functions. First, it allows the program to know the boundaries between precincts. Let me demonstrate by scrolling to the next match. This allows me to break the large text file into precinct-level chunks of text. Second, for each match, it stores the precinct number in the ID field and the precinct name in the name field, where I can retrieve them programmatically and give names to the precinct-level text file. Here is a regex that isolates the contest text on the first page of a precinct ballot. It leverages the fixed strings, contests and questions, and continued from front side of ballot to capture the text of interest into a variable named page. You can see the purple highlight that indicates the capture text. Maybe you can visualize how the program works. The first regex breaks the large text file into precinct chunks. The second regex extracts the text for a single precinct ballot, a smaller chunk. Thus, the program takes a divide and conquer approach to finding the text that it is interested in. The final step is to isolate the text fields that make up a contest. A contest is the name of an office, some instructions like vote for one, and a list of candidates vying for that office. A single regex doesn't work in all cases, so the program applies a number of them until it obtains a match. This regex is the simplest and matches the contest that consists of a contest name, voter instructions, and candidate list. You can see that there is a match. I will click on the capture groups, which the website will highlight in yellow. The name field contains the name of the contest, in this case, Justice of the Supreme Court. The instructions field contains the instructions to the voter. The candidates field captures all of the text between the instructions and the first write-in literal. Since the candidates' text follow a predictable pattern of name then party, the computer program takes over from here. No more regex needed. Again, I give a hearty thank you to the people behind this website. You programmers out there should bookmark this URL and save it for future reference. Here's how the sample ballot generation process goes. Step 0 is a manual process whereby I determine if the regular expressions from the previous election are still valid. If they aren't, I must tweak them for this election. After all, this process is nothing more than PDF screen scraping, and any kind of scraping is inherently dangerous. Once the regexes are working, I use the custom contest gen program to extract the contest names for each precinct. This was necessary for the 2021 election cycle, which featured lots of local contests. However, some cycles don't have local contests. The next step just breaks the large PDF into small PDFs and extracts the text from them into separate files. These files have generic names like municipality01.pdf, municipality01.txt. The next step uses a regular expression within a Java program to retitle the files with meaningful names. Instead of municipality01.txt, I will have 005@glen.txt. Step 3 is another program that uses the docx4j SDK to generate each precinct-level docx file based on the voter services text. Within this program are regexes to generate the contest titles and the candidates for each contest. This program knows the candidate's name and their party, so it can do endorsements on a party basis. There is another step that just organizes the sample ballots into geographic areas for distribution. This was my last enhancement, and I don't show it here. Here is a screenshot of the final output. Lots of files. Given 232 precincts, there are now 696 individual files. Let's look at the first three in the list. 005_@glen_vs.pdf is the voter services PDF file for the precinct of @Glen. 005_@glen_vs.txt is the extracted text file, and 005_@glen.docx is the Word file ready to be distributed. One of the goals of the project is fidelity to the specimen from voter services. On the left is a snapshot of the @Glen ballot from voter services. On the right is the sample ballot to be distributed after some simple touch-ups. One important point is that there is no chance for typos or misspellings. The document on the right gets the exact spelling as that on the left. If there is an error, it is due to voter services. Let's look at the sample ballot generation process using an old technique called data flow diagrams. These would be part of the program suite's technical documentation. In fact, that's where they come from. The first step is manual. Take the voter services specimen and analyze it. An important output from this step is determine whether the precinct ballots are 1 or 2 pages of the PDF. This cannot be determined by a computer program, at least not easily. Concurrently, the text of the large PDF must be extracted. This allows me to develop the regular expressions to be used by the custom programs that are downstream. The next step is to run the contest gen program. The regexes are stored in the Java properties file for the program. The other input is the text from the large specimen file. The output from the program is on the right. It generates precinct-level contest files for the precincts in the county. It also generates a separate common contest.txt file, which represents the contests that are common across all precincts. Now this slide should be read left to right, then top to bottom. The PDF box utility splits the large PDF into precinct PDF files. These are fed to the PDF box utility that extracts the text from each file. The custom program Ballot Namer processes these files and uses regular expressions and is able to give meaningful names to them. The final outputs from this process are the named files in the bottom right of the slide. This step is the workhorse of ballot generation, the Ballot Gen program. It takes the previously generated contest files and the text from each precinct ballot, and using the docx4j SDK is able to generate the precinct docx files. It uses a standardized naming convention to connect the contest file with the text file. Here's the step that wasn't described previously. The Ballot Zipper program takes a CSV file that maps precincts into what are called zones. Zones correspond to geographic regions so that the Word files can be distributed more easily. The output from Ballot zipper are zip files for one of 20 zones. Here is the final step. It is manual and it is completed by a volunteer from a zone. This volunteer must apply the zone's branding and message to voters for the election. The tool used for this step is Microsoft Word, which is pretty common across all Windows desktops. The Word files can now be commercially printed and distributed to voters. Let me quickly summarize what we learned. Patterns in mathematics are the basis for mathematics. These patterns are formalized in theorems. You can think of mathematics as the search for new theorems. Prime numbers do not have a predictive closed formula. However, there is a major theorem called the prime number theorem that covers the distribution of primes among the infinite set of integers. Patterns in computer science are represented by regular expressions. These are used to recognize substrings within very, very long strings. You can think of them as programs within a program because of their utility. Finally, regular expressions and open source software make things possible. For example, my sample ballot generation system. If you have any questions regarding this presentation, Java programming, or whatever, here is my email address. I would like to thank the organizers of the STEM Speaker Series for giving me an opportunity to give this presentation. And I'd like to thank you for listening to the end.